Hello friends, welcome back to my YouTube channel. In this video, we are going to discuss the inter-agent communication design pattern and how multiple agents communicate, collaborate and coordinate to solve complex problems. So without wasting any time, let's get started. So inter-agent communications. So if we talk about in traditional AI, so we usually have one big model doing everything. It's like planning, reasoning, executing, and validations. But in agentic AI systems, the work is divided among the multiple agents. So one agent plan, another retrieve the data, another execute the actions, another verify the results. So these agents must work together, not in isolation mode. So what is inter-agent communication, IAC? So IAC is defined as how agent talks. It is in the message formats or protocols. So how agents can coordinate, it's like a uh, task ownerships and hands off. Means if we talk about how agent means trust each other while they are working with each other. So in terms of validations, identify identity and expiry. So just think of all this rule of conversation of AI agents. So if I go without communication rules, means I without IAC, so the agent behaves like a people in a meeting with no agenda or rules. So agent repeat their works. Okay, and see what happened without the proper communication rules. So first is agent repeat works, agent conflict. So what the agent repeat works will do. So if agent don't do not share the status or results, so the two agents must fetch the data, the same data, and the multiple agents solve the same subtask. So this waste the computes and slow the systems. So this is the problems. Second one is the agent conflicts. So if we do without any coordination, if in work, so one agent say approve, another agent say reject, a third override the decisions. So agents start working against each other instead of together. So system become unstable. So without trust and timing rules, old messages trigger new actions and infinite loops occurs. So agent keep retrying forever. So the systems looks intelligent but it behave unpredictable. So IAC, inter-agent communication, is what turn multiple smart agents into a one intelligent systems. So agents are powerful individually, but the communications make them reliable. Next, communication protocol, how the agents talks. In an agentic AI systems, agents does not communicate randomly. They follow communication protocols. So a protocol is a set of rules that defines message formats, means how the message looks like, what field it contains, so task, data, ID, time. So and that, for example, it's a JSON and events and a structured text is the example is there. Next is message flow. So who sent the message, who received it, so in order, what messages moves, response expectation, is a reply mandatory or optional, should the sender waits or communicates, so what happens on the failure or timeouts, example success, error, retry and fallback. So common protocols are there. So these are the common protocols and their use cases. So request response request response protocol. So one agent asks, another agent replies. How it works? So agent A sends a request, agent B processes it, and agent B sends a response messages. And where we can use this request response? So in the data retrieval, tools, executions, and API like interactions. So for example, so planner agent asks executor agents to run a task and wait for the results. So this is for request response protocol. Next is event driven. So the agents react to publish the events. No direct requests. So one agent published an event and multiple agents may listen and each react independently. So the best use case for this event driven protocol is notifications, any state changes, and asynchronous workflow. For example, if the task is completed, that event triggers validations and logging agents. Next is broadcast protocols. So one message is sent to many agents at once. So one agent sends a message, all subscribed agents received it, and their use case is the system alert, global updates, synchronizations. For example, the system shutdown in 5 seconds, message sent to all the agents. Next is contract based protocols. So the agent agree on a strict rule and schemas. How it works? So message structure is fixed. Agent must follow the contract and invalid messages are rejected. So, so this contract-based protocol is extensively used in enterprise systems, safety critical workflow, and regulated environments. For example, financial or healthcare agents exchanging validated data. So, this why protocol matters. So, protocol prevents confusions, conflicts, and chaos in multi-agent systems. So, so protocol turns agent conversations into a predictable workflow. So agent ID, who is talking? In AI systems, many agents communicate at the same time. So the system must always know who is speaking and who is listening. So the agent ID gives every agent and every interaction a clear identity. If we go if we go without ID, so message whatever the messages are there that gets mixed up, and agents respond to the wrong task, and also the debugging become impossible. So why agents is an important? So agents ID help the systems to answer three critical questions: who sent the messages, identify the source agents and that enable trust and validations. Second one, who should receive it? So routes the message to the correct agents. It prevents accidental execution by others. Who is accountable for? So it tracks which agents made which decisions. It enable rollback, retry, and co corrections. So next is the type of IDs, agents IDs. So it identifies an individual agents. It's like, uh, for example, uh, planner agents and retriever agent, execution agents. So who is talking? So it identifies it. Second one is the conversational IDs. So it tracks a complete interactions or workflow. So it's group multiple messages into a one logical flow, and it helps agent understand the context. Next is message ID. It's uniquely identify each messages. It prevents duplicate processings, and that enable retrieves and acknowledgements. And the last is task ID, that identifies a specific unit of works. Means it links messages to a particular task, and that's help managing task life cycles like created, task created, running, completed, and failed. So how all these IDs works together? If we talk about in just in summarized way, in simple flow way, so a step one. So planner agents create a task, and that's assigned to task ID. Second step, start a workflow, and this assign a conversational ID. Third steps, sends a messages, that assigns to message ID. And fourth steps, the receiver checks the agent ID, conversation ID, and task ID. So only then the agent execute the task. So the agent ID brings identity, accountability, and other in order to multi-agent systems. So if agents cannot identify each others, they can't be collaborate. So this is all about the agent ID. Next is message expiry, TTL, when message dies. So in agentic AI systems, the agent exchanges many messages continuously, but not every message should be live forever. So message expiry, also called TTL, time to live, and is defined how long a message is valid. After this time, the message is considered dead and must be ignored. So why do we need message expiry? So message expiry ensures the the couple of critical things. So first one is old messages don't execute later. So if we go without TTLs, then the messages, a delay messages may arrive late. An agent may execute an outdated instructions. Agent don't act on the stale data. So agent decision depend on the current state only. If we do not go with expiry, then agent may use outdated context, and result become incorrect and unsafe. System remains the real time safe. So if we go without TTL, so query grow in in infinities, and infinity loops occurs again. So agents keep retrying old actions. So the TTL ensure that it should be automatic cleanup and controlled retries and stable systems behaviors. So how TTLs works? In that is a simple flow. So step one, sender creates a messages. Step two, add adds an expiry time or TTL value. And then step 3, retriever checks the current time. Step 4, if the message is expired, then message is dropped there. If step 5, if message is valid, then message is processed, right? So for example, in conceptual way, if the message is created at 10 a.m. at the morning, so the TTL time to live is setting is 5 minutes, and so after 10:05 a.m. the message will be expired. So if it is received at 10:06 a.m., so message get discarded. And if the message is received before 10:05 a.m. So the message is processed. So the OTP, it's like if we talk about the real time examples. So OTP codes, it's the OTP codes are expiry in a 5 minutes or 3 minutes or ten minutes. So message expiry ensures agents act on the right instruction at the right time. So TTL prevents intelligence agents from making outdated decisions. Next is full inter-agent communication flow. So this flow shows how agent safely collaborated from task creations to execution in an agentic AI systems. Think of it as a controlled conversations. It's not the random messages. So the planner agent is responsible for understand the goals and breaking it into executable tasks. At this point, the task exists conceptually, but no agent has executed it yet. Next one. So before sending the task, the planner assign identities, agent IDs, who is responsible for executions, the task ID, what exactly work need to be done. So it's having the clear ownerships, no duplicate executions, and full traceability. So the planner send messages using a protocol. So now the planner sends the task using a defined communication protocol. The protocol defines messages structure, expected response, execution rules, right? So the protocol used here is either request response, event driven, and contract based. So this ensures the receiver knows exactly how to interpret the messages. So the message include an expiry timestamp TTL. So the every message includes the expiry time of TTL, time to live, and what will be the purpose for this including. So it prevents a delayed execution, and it avoid stale actions. So retriever validates the messages. So before executing anything, the retriever agents perform validations. First is ID validations. So is this message from a trusted agent? Is this task assigned to me? Next is protocol validations. Is this message from the correct format? Does it follow the agreed protocols? Plus TTL. Is the message still valid? Has it expired? If any checks fail, message get discarded. Next, receiver execute or discards the task. If all the validation pass, so the task is executed. If any validation fails, so the message is ignored or logged. So why this flow is important? So its flow, it prevents the duplicate works, and it avoids conflicts between agents, and that ensure the real-time safety that make the system production ready. So agents don't trust blindly, so they verify before acting it. Next is next is why this pattern is critical. So inter-agent communication with protocol plus ID plus TTL is not optional in real systems. It is what separates toy demos from production grade agentic AI. So let's break it down. It prevents infinite loops. Without the clear communication rules, agents keep sending messages back and forth. No one knows what to stop, and the task get re-triggered and endlessly. If we go with this pattern, then the conversational ID tracked ongoing flow, TTL expiry kill old messages, and protocol defines what a task is complete. So agent stop talking when job is done. Improve tolerance. In the real systems, agents fails to network delay messages. So this pattern allow so messages retry using messages ID. Safe task reassignment using task ID, and it ignore the corrupted or expired message using TTLs. So when you scale from system from 3 agent to 30 agent to 300 agents, so if we go without this structure, it becomes chaos grow exponentially. And if we go with this design pattern, so the agent ID enables the routing, protocol standardized the interaction, and expiry prevent the overloads. And if we talk about production system demand, it's what its demand first is the predictability, observability, safety, auditings. So this pattern provides a clear logs who did what, when, how, and it's provides a safe rollback also. Okay, so this is all about the makes agent production ready, and where this pattern used in. So first is auto GPT like systems like multi-agent plan, execute and review. So the this pattern keep bonded. Enterprise AI agents, so it used in finance, support, analytics, and operations. So ID plus protocols is equal to enterprise trust. Autonomous workflow. So agent trigger other agents automatically, and its failure must be isolated, not the cascading. Next is tool called LLMs agents. So agents call API, database, and services. So incorrected or delayed calls can be very dangerous. So intelligent communication is a safety and scalability layer for an agentic AI, and a smart agents needs disciplined communication to be reliable. Next is, so this is the architectural of high level inter-agent communications. This is end-to-end flow of agentic systems of high level inter communications. So it start with the user request, interference agents. Here interference agents flow start the interference agents that receive the user query, system request, external trigger, API, and UI. So for example, analyze market risk and suggest an investment decisions. So the interface agents must validate the input, convert it into a structured start task, and it sends to a systems. Next, the coordinator agent takes the controls. This is the coordinator agents. It takes the control. So the coordinator agent acts as a orchestrator. So its responsibility is to understand the goal and decide which agents should be involved, and then control control the execution order and avoid conflicts and duplications. So the coordinator write the writes the task into a dynamic uh, blackboard. This is the dynamic blackboard. So dynamic blackboard is a the central communications and memory layer. It contains a decision enabling warehouse which has a four different key. The first one is blackboard status. This is the status. It tracks the system states, which uh, tasks are pending, running, and completed, and which agents are active. Next is private messages area, the agent to agent indirect communications, where the messages are written and read with the help of Blackboard. It includes the ID, protocol information, and TTL. Next is the knowledge area, that's having this is the data foundation of decision making. So it includes HTDB, means historical times data, RTDB is real time data, BSRDB business or sectors rules, FIDB is financial indicators, and UBDB user profile data. So all agents read right from shared knowledge base. Next is a specialized agent read from the blackboard. So now the multiple specialized agents work in parallel and each focus on a single responsibility, like technical technical analysis agent. So it analyze the technical indicators. It update the insights to the knowledge area. Similar way, fundamental analysis agents, it evaluates the fundamentals, write conclusions to the blackboard. Risk management analyst agents, so it access risk exposure, flag constraints of or warning. Next is monitoring agents, it observes system health, detect anomalies or failures. Next is the profile agent, analyze user behaviors and preferences, and it personalize insights. So each agents read required data, write back results, do not control the final decisions. And then decision making agent synthesizer, the the decision making agents. So it read output from the all the analysis agents, it's combine the insights logically and produce a final or recommendations based output. So this agent does not gather raw data, it's only region over validated over the output. And next is the validations and oversight. Before the final output, the monitoring agents ensure the system stability, and the risk management agents verify the safety and constraints, and coordinator confirms no expiry message, no conflict. All required agents are contributed here. And next is, so if the result is once the result is generated, then it goes to the interference agents and then users. So finally the decision is written to the blackboard, and interface agent is pick up it and format the response and send back to the user. So why this flow is very powerful? So here the no direct agent coupling here happening here. And I mean, if you see all are parallel executions, there is no conflict free collaboration here. It is scale and fault tolerance, and it's doing the enterprise grade decision making. So the blackboard is shared brain agents and are specialists, and the coordinator ensure like kind of harmony. So agent does not argue, they collaborate through shared knowledge. So this is one of the architecture here. Next is another architecture I taken. This is the protocol based message flow. So agent A sends an agent, this is the agent A and this is the agent B. So this diagram shows how the two agents establish the trust and communication safely instead of exchanging the message blindly. So agent A and agent B initializations here. Just I initialize it, right? Agent A and agent B are independent and autonomous agents. So each agents may be built by different teams running on different systems and use different internal logics. Next, first is protocol negotiations. So it decide how to communicate. When agent A propose a message format like JSON schema. So what is the interaction type, request response event driven, and what is the validation rules. So agent B accept, reject or modify the proposals. So this continue until both agree on the protocol types, required fields, error handling rules. So this step prevent misinterpretation. Once this is done, protocol negotiation is completed, then it goes to the protocol code generation. This is happening on the local basis. So once the protocol is agreed, so each agent independently generate protocol handling codes. So the code includes message, serializer, deserializer, validation logics, error handling, and timeout and retry. So no share code is required, only to share the rules. So once this protocol code generation implementation is completed by both the agents, then it goes for the test data negotiations. So before the real communications, agent agree on some kind of sample messages, some edge cases and failure scenario and invalid message example. So that ensure that both the agent interrupt message identically and it's avoid production's failures. So dry run, it's doing the dry run before the live goes. Next is once the dry run is done, then it's the protocol integration testing. So now the agent test communication end to end. Agent A send test messages, agent B validate and response. Both both will verify the message correctness, response behavior, error handling and timeout handling. So if issues are found, so protocol is redefined as step 2 to 4. Step 2 to 4 may repeats. Okay, 2 to 4. Protocol code generation, test generation is repeat. Okay, and next, once the protocol integration testing is completed successful, then it goes to the protocol communication, the live operations. After successful testings, agent starts real communication. It's a message flow like agreed protocol, validation schema, defined lifecycle rule. So each message is now includes agent ID, message ID, task ID, and TTL. So at this stage, communication is fast, predictable, and safe. So 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 why this architecture is important? So it prevent incompatible agent communications that enable independent agent evaluations, and it support the enterprise grade reliabilities, and that makes agent ecosystems scalable. So agent don't just talk, they negotiate, test, and communicate with the discipline. So protocol negotiation turn autonomous agents into trustworthy collaborators. So this is the second type of architecture. So third type of architecture is uh, agent ID and routing architecture. So this architecture represents a modern contact cell center call routing system, where the calls are identified, evaluated, and intelligent distributed. Here you can see here. So caller initiates the call. The caller dials the customer support number, and the calls enter the system through the technology telephony gateway. So at this stage, the no agent is assigned. The system knows only a call has arrived, and the IVR's next stage is the IVR. So interactive voice response, that is a call identifications. So this call first handled by the IVR. So IVR responsibility is to greet the caller, collect the information using keypad input of voice commands, and it identified the purpose of the call, language preferences, accounts, or customer ID. It's an example. It's a general case, like if you call to the customer care, then it will be say press 1 for English, press 2 for Hindi, and in the different way, press 1 for billing, press 2 for technical supports. So IVR reduce agent load by handling the basic query and classifications. Next, it moves to the ACD, automatic call distributor. So after IVR, the call moves to ACD. So ACD responsibilities that it evaluate the call based on IVR input, caller history, business rules, and it decide how important or urgent the call is. The call is categorized as a new regular or VIP. So ACD act as a decision engine for all the call prioritizations. Next is the call evaluations. New regular or VIP. So this stage determines the what is the priority level, SLA requirement, a skill set needed. If we talk about the VIP, so shortest waiting time, new is onboarding support, and regular is a standard queue. So this ensures the important caller are not treated the same as a general call. And next, once it's call evaluation done, then it's moved the call to the routing rules. So now the call enter the rules layer. So the rules layer that consider the call category, new regular VIP, and it's having the agent skill, agent availability, and load balancer rules here, and some kind of business logics are applies here. So for example, if the customer is VIP, then the senior agents will be handled. If we talk about the billing, then billing trained agents. So so this is where intelligent decision making happens. And next, the call distribution to agents. Based on the routing rules, the call is distributed to agent 1, agent 2, agent 3, agent 4. So distribution strategy may be round robin, list BG, agent skill BG routing. So it ensures the fair workload and fair resolutions. And next, agent handle the call. So the selected agent receive the call, and its the context from IVR or and ACD is already available. So agents can resolve the issue effectively, and it's avoid the repeating it asking a questions long handling time. So why this end-to-end flow is important? So first, it reduce the waiting time, improve the customer satisfaction, and it prioritize the VIP and critical calls, and it optimized agent utilizations, and it scale for long call volumes. So IVR defines the caller, ACD prioritize the call, routing rules decide the path, and agent deliver the solutions. So in the simple way, I can say the right caller, right priority, and the right agents. So this is all about the agent ID and routing architectures. Next, one more architecture I capture: a message expiry TTL and safety architectures. So this diagram how explain how and what happens when a message expires before reaching its intended receiver, and how the system handles such failures. So the sender creates the messages. The sender produces a messages, and while creating the messages, it sets the message payloads and message metadata and expiration timeline like TTL, and TTL define how long the message is valid. So if the TTL is equal to 30 seconds, so message must be delivered within 30 seconds. Next is message entered into the channels. Message into this channel. So this message is placed into a channel. It's a kind of queue, broker, or stream. So this channel is responsible for transporting the messages, holding it until the delivery. At this stage, the message is waiting to be consumed. Next is deliver attempt to intended receiver. The system tries to deliver the message to the intended receiver. This is the intended receiver. The possible reason for the delay is receiver is busy, network latency, system overload. So the message keep aging while awaiting. So next is the message expiration occurs, TTL exceeded. So if the message is not delivered before the TTL expires, so the delivery attempt timeouts, and this message is marked as expired, and the receiver never process it, and this prevents the execution of stale and unsafe instructions. Next is optional reroute on expiry. This is the optional rule. So instead of silently dropping the messages, the system may reroute expired messages and it preserve them for analysis or retry. So this is the configuration choice. And then message sends to the date letter. Finally, the message sent to the DLC date letter channel, a DLQ. Its purpose is to it stored failed or expiry messages and it that enable the debugging and monitoring, and it supports manual and automated recovery. So these messages are isolated from the normal processings. And finally, the system safety and stability archive. So the based on the TTL plus DLC date later channel. So no stale message executions, no diff infinite retries, no silent data loss, and it improves the better observabilities. So the system safe, predictable, and safe. So why this architecture is important? So it prevents delayed action from causing damage. It protects the real-time systems, and it makes distributed systems debuggable, and it is essential for agentic AI communications. So, so messages are allowed to live only for a limited time, and it expired messages are safely quarantined. The TTL decide when the message die, or DLQ decide date later queue where it goes. Right. And this is the intuit agentic workflow. They're having the planner, executor, and critics. So this is the planner, and this is the executor, and this is the validators. So this will uh, this will implement the inter-agent communication agents. All right. So this is all about the architectural mm, diagram and explanations. So thank you all for the today. If this video helped you to understand the intelligent communications, uh, don't forget to like, subscribe, and share. See you in next one. Thank you.